Now in the permutation, using the notation, using the formula, we have derived also the formula, and in theorem 1 what we gave, that if we are writing NPR, now it means, what this means, repetition is not allowed. This means repetition is not allowed. Now I told you if the repetition is allowed, then what are the conditions? Now just look here in the theorem 2 what we have written. The number of permutations of n different objects taken are at a time where repetition is allowed. Where repetition is allowed is given by n raised to power n. Okay, n raised to power r, sorry. Now let's move this example with this theorem with an example. Now I gave you an example. It was 1, 2, 3, 4, 5, 6 digits are given. Okay. Now how many 3-digit numbers will be formed when repetition is allowed. So we have to find 3-digit number when repetition is allowed. It means this place can contain all the 6, this place can contain all the 6, and this place can contain all the 6. So basically this means what? 6 times 6 times 6. Okay. So if we are writing P 6, 3 and repetition is allowed, then result will be 6 raised to power 3. That is what I have written here, n raised to power r. It will be 6 raised to power 3. Now 6 raised to power 3 means what? 6 times 6 times 6. Okay. So 3 objects out of 6, or you can say out of 6 taken 3 at a time. When repetition is allowed, we will be using n raised to power r, that is 6 raised to power 3. Okay. For this one, if we are going for this formula, NPR is equal to n factorial upon n minus r factorial, then it means repetition is not allowed. Okay. So this is about theorem 2.